When you are working with the design system component library, it's not uncommon to have a property that is limited to a number of well-defined string literals or design tokens, as well as open to any string value to allow the user to provide their own custom value, for example in pixels. However, the simple annotation that you might use for such a property within TypeScript will completely mess up autocomplete, and that is what we will demo and fix with the more advanced annotation, so let's go. Here's the type that represents the kind of problem that we are trying to solve. We have a type called padding that takes well-defined design tokens, small, normal, and large, as well as allows the user to provide any arbitrary padding value. Now before this padding ever gets rendered to the screen, we would pass it through this utility function called getPadding, mapping the design tokens to their values and leaving untouched any other value that might be passed in. Now let's look at the developer experience when someone tries to use a value of type padding. They can provide any of these design tokens as well as any other arbitrary string. Now what you might not realize is that TypeScript has already figured out the fact that all of these string literals are a subset of the string type, and therefore it has collapsed padding into a single string type. This means that whenever we try to assign a value to something of padding type, we do not get any autocomplete for these string literals. If, however, we were to remove the string type from this union and then try to assign a value to something of type padding, we get a nice autocomplete for the three literals that are present over here. However, removing string from the union means that strings are no longer valid padding values, and we get an error when we try to assign 8 pixels. Now the thing that we want to achieve is to still allow arbitrary strings, but provide nice autocomplete for the well-defined design tokens. Now the workaround that we are going to use is not based on a language specification, but rather on the internals of the TypeScript compiler and how it skips this aggressive reduction of a primitive type with its literal union. For example, the union of string, a primitive type, with a union of literal strings. Instead of doing a union with a simple string, we do a union with the string combined with something else like an empty object with a simple intersection. With this change in place, the literals as well as the string are preserved in the final type of padding, and whenever we try to assign a value of type padding, we get nice autocomplete for these literal members. Additionally, padding takes all strings. For example, it takes this 8 pixel value, and it can also be assigned to a string. For example, when we return the final padding value from the getPadding function, TypeScript is happy to treat it as a primitive string.